Section 2.4 Python classes. Classes are a key concept in the object-oriented programming. Using classes, you can bundle data and functionality together. A class is a user-defined template or prototype from which various objects can be created. In this section, you learn how to initiate classes and how to refine them and how to use them. Let's see this example. In this file, we define class named polynomial, and this is a docstring. And there are two functions defined. Functions in a class is called method, and that init is a special method. It's constructor, and once the object is made from this class, okay, that is creation of object P2. Object P2 is made by calling this line along with the coefficient 1, 2, 3, and then here the init will be executed so that 1, 2, 3 will pass through this coefficient and assign to here self.coef. Okay, so that one will save here now 1, 2, 3. That is executed when it is the object is created. Okay. Now that is extra function user defined, and now once it is made the parameter with self prefixed, then that will be shared for all other functions methods. So here in degree, that is shared so that if you call execute the degree, then that length is measured, and in this case it's 3 and -1, so that it is second order polynomial, quadratic polynomial. And of course this one is representing now x squared, 1x squared plus 2x plus 3. Okay, this is a second order polynomial. Here, practically, we try to print out P2 for the object, now the coefficient, coef, P2.coef, the output is 1, 2, 3. Now, P2 degree, then return value is 2. So it is a simple initial polynomial class. And that is for execution. In fact, this portion is class. That is now by executing the file, and then it will be used as main, so that here this portion is executed. Okay. Okay, I guess I explained most of that. And here, okay, the self parameter is required and must come first before the other parameters in each method. Okay, the self is required and comes earlier than other parameters. And also here, whenever we make an object from the class, we need to provide argument for parameters except for self. You don't have to give any argument for self. Just for others, you have to give the required data. So here, when we construct an object, 1, 2, 3 is given, the array is given for coefficient variable. Okay, now variable self.coef prefix with self is available to every method, and it is accessible by any object created from the class. Okay, so that one is accessible for other the method functions, and so it is shared an object inside object. That's some detail and some thing you have to remember when you are implementing a class. Okay, now we'll try to define the polynomial class here. Okay, here we add this one. This is now not a function, but it's assignment. This is a class attribute, and that will be also shared in everywhere. Now, but you have to use along with the class name and dot count if you want to do want to change the value, and then you have to use in this way. Now that is the same as original one. Now it is assigned, so it doesn't need anything, so that it's initially self is assigned along with only one value, the list of one value. And here now del underscore 2 underscore del and 2 underscore, that is also defined. That is called destructor. And once you delete object, then that one will be executed. And here, so that count is now, once it is object is made, then it's changed into 1 because it's an add 1. But if you delete some object, then it's subject 1, so that it is a sort of count of opened object, constructed object. So we are using that. And also destructor called a polynomial object is deleted. This one will be printed. Okay, degree is the same as earlier, and for polynomial evaluation, we define here evaluate, and for given array of points, for each point we try to evaluate function value by using Horner's method. Because it's polynomial, you can use Horner's method to get the function value. So that we defined this polynomial class by adding and changing functions. Or sometimes like assignment can be added. Okay, and here we execute this file, so it can be used as main. So first of all, we construct poly1, and we try to print out the poly1 quotient. And now for poly1 quotient, we reassign, reset, and try to print out. And here we try to print out poly1 degree. Okay, let's see this portion of output here. That is now, that's executed, and poly1 default quotient is this one, and poly1 quotient after reset is 1 to -3. We changed it. Now degree is 2. Okay, that is poly1 part. Now we'll go to poly2. We construct one more object. Now 1, 2, 3, 4, 5. So that fourth of the polynomial, for the fourth of the polynomial, the coefficients is given. And here now after reset, we'll try to print out for poly 2, and we try to measure degree. And here, okay, we'll see this poly 2 portion here. That is now poly 2. The coefficients after reset is this one, and degree is 4. It's well working. Now, here, in this execution, now number of created polynomial can be printed along with a polynomial count. Each construction that will be executed so that start from 0. Now polynomial count will be twice added, so that that is now 2. The value will be 2. Okay. And if we try to print out, then that'll be 2. And here, that's delete command, and one object, the polynomial 1, is deleted. That one is now keyword, a sort of a keyword, and it's now working as a command in deleting poly1 object. Then here, this portion, that method will be executed, and after deleting, that portion is executed, so that now from 2, and it is changed into 1, and this one will be printed. Okay. Then after that, we try to here and print out the polynomial count, and here poly 2 evaluation along with -1, 0, 1, 2 for these 4 points. Now the polynomial values will be printed out. Okay, let's see what the result is. Okay, now number of created polynomial is 2, and after deleting here, this one is now printed, and number of polynomial after a deletion is 1. Now here, polynomial evaluation for this point, the polynomial values are this, and this one is extra print out. So that once execution is done, then basically the constructed objects are all deleted, so that this one is executed. So that line is printed out at the end. So here, that is extra one. That is now because finishing execution, deleting everything, the objects, so that this one came out. Okay. Okay. Here. Okay. The count is a class attribute, and here class attribute can share. Can be shared for all objects. Okay. Now I guess I explained everything around there. And okay. Now so far we initiate a class and we refined. Now we'll see inheritance. That means that for class, we may try to construct a special version and use like a new class, but for given class, we can get some specialized operations. And in this case, the specialized class is a child class, and the original one is parent class. We'll see here example. Now that is the initial polynomial. For simplicity, I put here now the initialize the polynomial class. Okay. Now for that one, we can define a child class in this way. The name is quadratic, and inside a parenthesis we put polynomial. That means that quadratic will be a child class of polynomial. So we write down here the doc string, and here inside you can define init, because it's also a class. You can define here init, and here now if we're using super that one, then this the line will try to get everything from the parent the class, so that assignment will be here now done along with this one. This one is inherited here. Okay. Now we have one more variable. Self power decrease is 1. That means that once numbers are given, number array for quotient, for example, now, and earlier we tried to use array 1 and 2 and 3, 3 numbers, but that one is representing 1x squared plus 2x plus 3. Now this power is decreasing order, so that default is power decrease. So it's 1, and after constructing object using quadratic, you can access this one. If it is not 1, then probably that is now increasing the power. Okay, here we define roots. That is, now here for the coefficients, because it's quadratic, it is given with only 3 values, because and quadratic requires only 3 value. So that for 3 value, A, B, C, once the power decreases not 1, then change A and C, so that here if you change first and the third one, then that is now 3, 2, 1. That is now representing 3x squared, and here plus 2x plus 1. Right? So that once it is given in this way, along with power decreases not 1, okay, that means that power is increasing, so that eventually that one is the same as that 1 plus 2x plus 3x squared. And the other way, you can write down this one in this way. Okay, so that 1, 2, 3, once power decreases not 1, then representing this one. Okay. But anyway, inside, for simplicity in programming, we just change the position, and by using, and after swap A and C, and after getting discriminant, and by using formula, quadratic formula, 2 roots are made and collected and returned. That is the method roots. And here, this degree is automatically 2 always, because it's quadratic. So here, now earlier one, this parent class has the function method degree. Now by defining here another one, this one override the parent degree. Okay. Okay, in this way, you can define the child class and use it. Okay, now for the quadratic child class, and we call quadratic class in this way. The file name is classes, so that we import everything from classes. And here, now construct an object, quadratic, 2, minus 3, and 1. So that is one object, a quadratic object. And here, root can be found. But right now, for the object, and initial power decreases 1, so that here, that 231 is representing now 2x squared minus 3 x plus 1. So the root will be gotten from setting this 0, so that is now 2x, okay, 2x and x separation, and that is 1 and 1, okay, both are negative, so that eventually you have x is here 1 and a half. There's values 1, this is half. So we have 2 here, the roots anyway. So this printout will make that output. Now here, for given 2 minus 31, we change the power decrease to be 0. That means that power is increasing. That means here, okay, this 1 along with this one now representing that one along with that assignment representing this is 2 minus 3x plus x squared. So that if we try to find the root, then we solve this one. Now, for that one, in fact, the left-hand side is the same as here, x minus 1 and x minus 2. So that here we have x equal 1 and 2, two solutions. After changing the variable, now if you try to get the root, then root is now 2 and 1. Okay. Okay, so we saw how to construct a child class, and here the inheritance can be well understood. Okay, finally, for Python basics, we try to consider Python keywords. Keywords are some predefined and reserved words in Python. And here, and, or, not, if, else, and so on. And here, DL, and break, and continue, and import, and so many are predefined and reserved, so that you cannot use it as your own variable. So here we used DL somewhere earlier. Okay, over there. Okay, now, okay, in fact here, that is also the keyword. Basically is deleting one object. Okay. Okay, that's the end of section and end of the chapter. Thank you.